Cement is often viewed as one of the most challenging categories in all of decarbonization, and that really draws me to it. Concrete is a trillion-dollar industry, and it's one of the most scaled and oldest industries on the planet. There's immense opportunity for innovators that can find ways to make the same cement and concrete that we need and use today at scale, but without the carbon. My name's Cooper Rinzler. I'm a senior partner at Breakthrough Energy Ventures, where I focus my life on climate tech innovation, and I'm extremely excited about the climate tech map. I work in clean cement and concrete because concrete is the literal foundation of society. There is now more man-made mass on the planet than biomass, and most of that is concrete, of which the key ingredient is cement. Not only this, cement is often one of the categories that in projections for emissions scenarios is the last to fall. And as someone who really cares about climate tech innovation, that's a challenge to me to say, let's find solutions to accelerate the decarbonization of cement and concrete. We need innovation in clean cement and concrete because concrete is an important source of emissions on the planet, responsible for almost 8% of global CO2 emissions. Not only that, cement and concrete are actually the lowest emissions per unit mass products that we make. That means that they naturally carry a very high green premium without innovation. In addition, cement has an extra special challenge, which is that more than 60% of the emissions of cement come from process emissions, the chemistry of the rocks that we use to make cement today, and only 40% are from the energy. That means even if we decarbonize our entire energy system, there will still be massive emissions from the cement and concrete sector. But there's reason for hope and opportunity too. Concrete is a trillion-dollar industry, and it's one of the most scaled and oldest industries on the planet. There's immense opportunity for innovators that can find ways to make the same cement and concrete that we need and use today at scale, but without the carbon. There are lots of opportunities for innovation in clean cement and concrete, but I think the most promising is in emissions-free ordinary Portland cement, or OPC. And that's because OPC is, to first order, all of the cement we use today. More than 95% of all cement use is ordinary Portland cement. It's the same material that we've been using for over 200 years. Finding alternative ways to make that same material, but without the carbon emissions, is a true grand challenge. That grand challenge is enhanced by the fact that ordinary Portland cement is today made from limestone, which itself contains carbon dioxide in the very rock itself. Finding new feedstocks to make the same cement that we use today is a massive opportunity. Another opportunity for innovation in clean cement and concrete is low clinker concrete. While cement is the source of our emissions, concrete is actually the building block that we use. Every year we use almost 40 billion tons of concrete, and cement's the key glue that holds that together. And cement is mostly made of ordinary Portland cement today, OPC. But what if we could use less of that high emissions ingredient to still get the same effect in concrete? Low clinker cement envisions that we can find solutions to displace parts of that cement with alternative materials that are lower cost, lower emissions, and still high performance, so that the buildings that we use the minimum amount of that high emissions intensity ingredient as we can. There's immense opportunity in this space to take the clinker content of concretes down by a factor of over 2. I'm excited about the moonshot of carbon-negative concrete. The built environment uses more than 40 billion tons of concrete every year, and today, that's a source of immense emissions. What's not known by everyone is that that very concrete that we pour, over time, actually absorbs carbon dioxide from the atmosphere, making buildings a sink. The problem is, we emit way more CO2 in the process of making concrete than concrete can ever absorb over the course of its life. But if we found a way to not only remove the emissions of making concrete, but find a way for the built environment to be a place that we store carbon, then suddenly the built environment could be a place that actually could take billions and billions of tons of carbon and sequester it every year, being a source of carbon negativity. It's one of the few industries on the planet that actually moves enough atoms that if we make it carbon negative, it can make a macroscopic dent on carbon emissions. While cement and concrete can often be the largest volume of materials used in infrastructure projects, they're often a very, very small percentage of the total cost of that project. That means that construction firms are often not willing to take risk on new materials. Make sure you really understand the needs of the construction firms and the end customers and their willingness to adopt new technology before you go too far down the road of your own innovation. Something I wish people understood about cement and concrete is that we use so much of this material because it's strong, but also because of some of its other material properties, like its ability to be reinforced with steel, another really strong industrial material. The majority of concrete use is reinforced concrete. That means that any new cement innovation needs to enable us to continue to be able to reinforce that concrete if we're ever going to decarbonize the bridges and buildings that we need to at scale.